Good morning, everyone. Welcome to our webinar, New Features in HDF5 1.12.0. I'm Elena Pourmal with my colleagues Jordan Henderson, Gerd Heber, and Elena Cooper, who will help with presentation and will answer questions. In your control panel, webinar control panel, you will see the place where you can type your questions. We will appreciate if you type them as the presentation goes. We will answer the questions at the end of the webinar, and we also will post more comprehensive answers with the recording of this webinar on forum and our website. So with this, let's start. Okay, my mouse is not moving. Let's see what's going on. It's not reacting.
It moves now.
No?
Your mouse is moving.
Yeah, but okay. It just probably some delay. Before I start talking about HDF5 1.12 features, I would like to emphasize that HDF5 is an open source software and is freely available, including all releases and HDF5 binaries that we provide. HDF5 binaries are for Linux, Windows, and Mac. If you need help with building other binaries or building another platform, please contact us and we will help as much as we can. During 2020, our focus will be on performance improvements, enabling applications to access data in the cloud and object store. And HDF5 was born with HPC, and we probably will die with HPC. HPC still remains our focus, but we'll be focusing on facilitating convergence of HDF5 on HPC for HPC and cloud applications. And we are also very interested in working with machine learning applications and improving HDF5 to work with those applications. So this is our focus in 2020. In terms of the releases, we are working on our 1.12 beta release right now. It's supposed to be done by December 31st, so it's kind of imminent. We are looking into stabilizing last interfaces. File format is stabilized already, and full release in mid-January 2020. So essentially, it's imminent. After that, we'll have 1.12 releases every 6 months, as with our regular maintenance release. We will continue with 1.10.6 and with 1.10 releases, and 1.10.6 is imminent. It's coming any day now, and once again, it will be supported every 6 months. There will be new maintenance release, and we still plan to terminate 1.8 line of releases, and last release will be in summer 2020. It will be 1.8.22. So please start migrating now and contact us anytime to help you with this migration. Now, topics and demos for this seminar. I will give an overview of 1.12 features. We'll talk about some performance improvements that we were able to put in the release, wall connectors, new VFDs that are coming with the release, and new references that we added. The release candidate is available already, and there is an announcement on forum. This is the link to the release, and it has Alpha 1, and it will have beta release there. So if you want to learn about the new features in the release, you can go to our website, our support portal, go to documentation, then HDF5, and under HDF5 Application Developers Guide, you will see release-specific information. This is the fastest way to find which release, major release has which features. Those pages will have links to all kinds of documentation, and features will be marked if file format changes is needed if you want to use this feature. For example, new references will require file format in HDF5, so there will be some incompatibility if you're using this feature. You will find all this information on those pages. So let me talk first quickly about performance updates that we were able to do for this release. Some of you probably saw those graphs before, and what we discovered for some applications, like for example CGNS, moving from 1.8 to 1.10 was a spike and really drop in performance, but starting with 1.10.3, we fixed a lot of issues, and performance for CGNS applications really were not affected. And we show that with 1.12, we still stay on the same level of performance. We've developed going a little bit high, but we will be working on improving this. While on the right, you see the graph that writes, it's application that writes 5K datasets with different versions of HDF5, and you see that it was a huge spike with 1.10.1, 1.10.3. We went a little bit down, but really with 1.10.6, we gained another maybe 15 to 20 performance back. But our goal is to, in the next 6 months, to come to the level of 1.8 as much as possible. So we committed and we continue working on performance improvements. Also, please remember that some enhancements that you saw in the latest 1.10, they're available in 1.12. And this graph represents the enhancements that were done to the library plus to application to get to the best performance by its 32,000 processes, MPI ranks that write data, and green line, this blue line represents the performance of application when each rank writes to its own file, so it's kind of in MPI role known as the best what you can get, but writing to the shared file is always the challenge, and this was the curve that previous performance with HDF5 library. So by tuning application and by tuning library, we were able to get to this green line. So performance can be improved. Stay on top of enhancements that are coming in HDF5 library. It's all documented. And if you have any performance problems, please contact us. Please report, and we will work with you to make it to performance to happen. One of the deficiencies in 1.8 and 1.10 is hyperslab selection is very slow, especially for big data sets. Big, we mean going more than gigabyte when you're subsetting data sets from 1 gigabyte files and more. We did enhance HDF5 in 1.12, and performance improved by an order of magnitude. It was a big change in 1.12. It would be very hard to port to 1.10. We are considering porting it back, but we do not promise. So if you have performance issues with hyperslab selections, please try 1.12 and report any remaining issues to us. You can post it on forum or contact directly help at HDF Group. So now I will be talking about new library architecture that allows us really to extend HDF5 and access data stored not only on POSIX file system like it was designed for, but to any different other type of storage. So what was done in HDF5 1.12, we added new layers into the library. The first layer is called virtual object layer. And the goal of this layer is to intercept calls from HDF5 APIs and redirect those calls into native library as it was before and the regular path, and I will talk about this shortly, or to go through a new mechanism which is called wall connectors that you see here that really can talk to any other type of storage. It can be object store, it can be cloud, it can be hierarchical memory, and so on. So underneath, if you go this route, you will not have HDF5 file as you used to think about it, the linear stream of bytes that conforms to HDF5 file specification. But this route allows you to use existing HDF5 applications and talk to different type of storage. And you will see the demo of this with using DAOS wall connector, talking to DAOS object store that we created. So on the next slide, I show you there is an open repository of wall connectors. We are working with community. If you're thinking about writing your wall or you want to learn how to write, please look into this repository. You will find many connectors that are in the works or will be released. And one of these connectors is asynchronous HDF5 connector. This is so-called pass-through connector that can work with HDF5 native library and with any other wall connectors that library can use. What it actually allows you to do is uses a separate thread to schedule HDF5 operations, and that thread is only working when application doesn't do any work. So it doesn't interfere with performance of application. But from application point of view, it looks like it's hiding and overlapping I/O with computational part of application. It is implemented using Argobots, and for initial performance, we got like more than 9 times performance improvement in applications. There's a paper. It comes from our collaborators from Lawrence Berkeley National Lab, and if you're interested, please try and see how it works. So now we'll be talking about terminal wall connector that allows you to put data not to HDF5 file, but to object store. And the example of this object store will be DAOS object store. And Jordan will continue from here.
Yeah, thank you, Elena. So yeah, the HDF group is working on a wall connector to interface with a new object store engine called DAOS, which stands for the Distributed Asynchronous Object Storage. And as you can see here, in DAOS, there's a concept of a container, which is a collection of objects. And we essentially map an HDF5 file directly to a DAOS container. And then within that container, each object has essentially a various amount of key value pairs in them. And so you can see in this diagram, for example, we map HDF5 groups to DAOS objects. And within that object, we have key value pairs that store things like the internal metadata of the group. So this will be things like the group creation property list, the reference count of the group, and things like that. And then each link inside the group is essentially a key value pair where the key is the link name and then the value is the object that the link's pointing to. And the same for HDF5 data sets. You can see here we have some key value pairs for the data set creation property list, the reference count for the data set, and then the data set, the data type, and data space. And then for chunk data sets in particular, there are several key value pairs for each individual chunk, where the key is the chunk's coordinates, and then the value is the record data for the chunk. So then I'll go ahead and give a short demo, basically just showing how you can quickly switch between the native HDF5 wall connector and then the DAOS wall connector. So over here, we have a very simple HDF5 example. So in this example, we just create a file called example.h5. Then we create a data space with 4 elements in it, create a simple integer data set with that data space, and then write 0, 1, 2, 3 to the data set before we close everything. So go ahead and run that. Now you can see that we have our new example file here. And then if we run h5 dump on that example file, you can see here's our data set in our file. We have our 0, 1, 2, 3 here, so very simple file. So I'll go ahead and actually remove that file. You can see it's gone here, and h5 dump can't access it anymore. And over here, I will go ahead and start the DAOS server. And then I will also start the DAOS agent, which is needed to allow the client to interact with the server. And then on the client side, I need to create a DAOS pool, which is essentially just a collection of containers. trying to grab this real quick. And then I have a simple little script here which takes that DAOS pool and then just sets a couple of environment variables. So these bottom 4 environment variables are just needed for DAOS and can essentially just be ignored. But what's important is these 2 environment variables up here set for HDF5, and these are what actually allows HDF5 to switch from the native connector over to the DAOS vol connector. So first you have your HDF5 plugin path, which some people might be familiar with if they use dynamically loaded filters. So you want to set this to the directory that contains your build vol connector library. And then your second environment variable is HDF5 vol connector, and you set this to the name of the vol connector itself. So by setting these 2 environment variables, HDF5 will then be set up to load your vol connector and use it in place of the native one. So since we're set up for DAOS here, I'll go ahead and run that example again. And you can see this time around, without changing the application, we're now getting messages from the DAOS vol. So we created our file here, we created our data set, and we wrote a little bit of data to it and then closed the file. And you can see here that we haven't actually created that POSIX file. It's now stored over in DAOS. And so now if I run h5 dump again on that example file, you can see we get a message from the DAOS connector, how we open that file. You can see here's our data set stored over in DAOS, and then you can see here from the connector that we closed that example file.
Thank you. So now switching gears and going back to presentation. So now we'll talk, return to our architecture slide and just continue. We talk about DAOS connector. We will have more on January 17th. We'll be talking about our RESTful and highly scalable data server that allows HDF5 applications, meaning from any languages, Fortran, C, H5Py, to access data that is stored in cloud. Stay tuned for announcement. It will be it will come into forum soon. Now, another direction we took is to explore our existing mechanism in HDF5 library, and the existing mechanism to put data in storage was our virtual file drivers, and we have from the beginning drivers to talk to POSIX storage, to use parallel file systems. We're now developing Swimmer VFD that you saw, probably some of you saw demo a month ago. And in 1.12 release, we're providing you with two more virtual file drivers, S3 VFD and HDFS VFD. S3 VFD gives application access to the file stored as an object in S3, and HDFS to the file that is stored on Hadoop file system. So the next slide will show you, or next few slides will show you how you do this. Very little change is required to application. You only need to tell application that file resides in some other storage. In this sense, in this example, this is API to tell library that file is in S3 bucket, and credentials to access S3 bucket are passed to application through the structure, or it can be in configuration file. And S3 is not different from any other regular drivers we provide. It just transfers offset and size of bytes to read, like we will read from POSIX file system, into range get commands to get bytes from HDF5 stored in S3. It is expected that it's not high performing, but it gives you access to the file in S3 immediately, and more improvements are in pipeline and roadmap for this driver. So in my demo, I will be using example that exists on our website, and it was modified to access the file on S3, and then we'll be using h5 dump to print first 10 elements starting position 100 It is like row 101, I believe. First 10 elements in this from this radiance data set from the file, the same file stored in S3. So in my directory, I have two examples, H5XG visit and modified one for the cloud. And you can see the difference between two examples is the source code is only name of the file, file on local system and file with the same name but on Amazon, and credentials and file access property list is set up, then it passed to H5 open. And now I use H5 CC script as usual to compile application H5G visit cloud example. There is no difference here, creating executable visit cloud. And when I run it, you will see that it prints the content of H5 file. It lists all groups and data sets. This is kind of real-time pre-recorded demo. So now I will be using H5 command, and I will use special flag to specify use read-only S3 driver and location of the file using URL. And here is my data. So no difference from how you work with the file on the local system. So now Gerd will be talking HDFS VFD.
Thanks. Yeah. The HDFS VFD is, once you have seen one, it's pretty clear. So this is just a reinforcement on that pattern. So what we can do with S3 at the VFD level, we can do with HDFS or pretty much any other storage that has a byte level interface. And so we went out, and as part of your Hadoop distribution, you are getting a support or compatibility library called libhdfs. And today I'm just going to walk you through a blog post that we published earlier this year. And there's an accompanying video. I invite you to watch that, but I'm going to give you sort of the highlights here in 5 minutes. In here, we basically talk about basic things like taking an HDF5 file, copying it from a local file system into HDFS, listing the file structure using a tool like H5LS, print detailed information using H5 dump, extracting data sets just to convince ourselves that the standard command line utilities just continue to work the way they work against the local file system. And then if you would like to use this in a programmatic fashion along the lines that Elena just used the S3 VFD to modify this example, if you're familiar with Hadoop, I'm sure you're familiar with Hadoop streaming, and I'm showing you a little example of how to use Hadoop streaming and that HDFS VFD to examine sort of in a MapReduce style fashion collections of HDF5 files. Okay, these are just stand-up directories. If you are Hadoop experts, this is going to be pretty boring stuff. But you need a version of the HDF5 library, so you will have 1.10.6, but these things started to work in 1.10.4. And Hadoop, again, we haven't done exhaustive testing of which Hadoop versions are compatible with this, but since we are not doing anything Hadoop specific, as long as you have libhdfs, you should be good to go. And of course, in Hadoop file system, you need that. And then you want to pay attention, as with any Hadoop application, that you have your setup, your environment set up correctly, things like class path. And then since we are having here some unmanaged code, you want to look at the LD library path, that sort of the right things get picked up and so forth. And then do a simple test of that your HDFS file system is up and running by just simply running a simple HDFS DFS ls command, for example. Now, the first thing that you want to do is take your favorite HDF5 or NetCDF4 file and copy it into HDFS, and that's as simple as an HDFS VFS copy from local command to copy that into a destination of your choice in your Hadoop file system. And then if you have built a version of the HDF5 library with that HDFS VFD enabled, you're ready to go to use the command line utilities. And as we saw with the S3 VFD, for a tool like H5LS that basically lists the contents of an HDF5 file, you have to tell the tool that rather than using the default POSIX virtual file driver, you would like to use the HDFS virtual file driver. So you would say here --VFD equals to HDFS. And then as you need AWS credentials to do something in the Amazon cloud, for a Hadoop file system, you typically need to adjust that to your local configuration, the port on which your main node is listening, and then you might have, if it's Kerberos authentication, you will have to set something about the Kerberos ticket cache and things like that. But we are going with the defaults here. And then you can just run H5LS and you can list things recursively. So -R, for example, would mean in the sample file, we are just sort of recursively going through. And the same thing works. I have as an example here, a netcdf file, a netcdf4 file to be specific, that's a little bigger. And then you just get the standard familiar H5LS output. The same goes for H5 dump. So all the tools that support accessing HDF5 files with different virtual file drivers can support that. Unfortunately, between the tools, and that's more for historical reasons, the naming of the options that support using different VFDs is not consistent. So we just saw in H5LS, it's --VFD. For H5 dump, it's --file driver. So I apologize for that, but there's nothing I can do about that at the moment. So if we run H5 dump on this, we get the familiar H5 dump output, and likewise for the netcdf4 file, we get a pretty extensive load of information here. And of course, not only can you plot or print the structure of such an HDF5 file, you can also extract data, just the usual way you do that with a regular file system. Now, last but not least, let's talk about how you would use that in your own application and MapReduce, for example. Again, if you're a Hadoop user, you know what Hadoop streaming is, but the basic idea is rather than having to write a Java application, you can use pretty much any application that can read from standard in and write to standard out. And that application can be a shell script or an application written in C or Python script. It doesn't really matter as long as it adheres to that standard in, standard out paradigm. You can run them as mappers and reducers with the MapReduce framework. And there is a link here to GitHub repository where I put the C code, the mapper, and the reducer. And the idea is basically that, so that repo is here. So you have the mapper and reducer code, and then a little wrapper script that runs this all together. So the important lines, what this tool does is basically, we have a collection of HDF5 files, and I would like to iterate over them and just for each file report how many groups, how many data sets, and how many sort of committed data types are present in that file. And then basically my reducer would do a reduction over all files that are present in a directory structure and give me sort of a total head count, a statistic. And so the only change, I believe, is the mapper code. So in the mapper code, you have sort of the usual H5 iterate callback here, But then when it comes to opening the file here, you see I create the struct and populate the Hadoop configuration data, if you wish. And then all you really do is the same thing we did earlier with H5P set to set this file access property list as 3. In this case, it's HDFS. And that's it. That below this line, everything is just cookie cutter HDF5 stuff and would work with any other data store. And then likewise on the reducer side, we are sort of assembling all these outputs together and then print the results. And you can see all that in detail in the video. And I think, yeah, of course, as an input, you provide a list of the files, or you could write code that would generate that list through an iterator or something like that. And then here's the script, and this is the output from an actual run. So good news is this was just for reinforcement, whether it's HDFS or S3. If there's another storage that you have in mind, you can look at the code that is available in the open source and try to do it yourself. And if you can't get it quite right, well, talk to us, ask on the forum. It's really not rocket science. Thanks.
Yes. So now we're switching gears back, and we'll be talking about references that we updated in 1.12 release. Just waiting for screen to, oh, it's here, right? Okay, so many of you probably know that in HDF5 we have reference data type. It is used to reference objects that are stored in the same file or dataset regions from datasets. You can store references to those in datasets. And up to 1.12, that capability was restricted only to referencing data in the same file. You could not reference in 1.10 or and before objects that are stored in another HDF5 file, references to the dataset regions and dataset stored are another dataset in another HDF5 file. So with 1.12, this limitation is limited, and now it works with external files. So in this picture, you see that we have, where is my mouse? We have datasets that have references to regions, to the files that are stored in the same file. But now we have external file, HDF5 file, and there is a dataset that can point to different objects in file A. We also introduced references to attribute data type that was we never had before. So now you can not only reference objects like groups and datasets and regions in datasets, but you can also point to attributes attached to the dataset. For example, here, this dataset points to the time step attribute attached to the image. And there's also another attribute here attached to object in different file, but it can be referenced from this file. So this is going, you can connect now objects and files with a way of those external references. As a consequence of this, we have to create, we updated, to give this functionality, we had to update our data model, and with APIs we had, we really couldn't accommodate it. So the decision was made to introduce new APIs that will work with new types of references, and they also can deal with all types of references. If you go to our website, there is a document that describes in detail how those references work. But here you see that APIs were introduced. It's a little bit clear that we work with which type of reference we work. We create reference to attribute, we create a reference to object, region, and we also have ability now to copy references and reuse them. We added functions to query references, and the first function that is kind of very useful here is you can get type of reference. Is it reference to attribute, object, or data set, region, and then using that type, you can query the file name where this reference, the object resides that it reference to. You can query attribute name and object name. So it is much cleaner and simpler APIs that we had before. And of course, you can open functions. We have open functions to open references for attribute, object, and region. I want to say a few words about a compatibility report, and since I have time, I will go and publish compatibility report for 1.12, comparing it to 1.6. And the reason I'm bringing here because compatibility report can be very confusing. You will see added symbols that are kind of expected, but you always see you see the symbols that were added for pass-through wall connectors that wall developers can use. But then you see removed symbols, and when I saw it myself, I was, oh my gosh, what we are doing here? But don't be scared. If you remember, in HDF5, we use API versioning to modify APIs and allow users to choose API they need with the minimum changes to applications and using versioning number or using macros. So when you see in compatibility report remove symbols, those functions are not removed. Those names became now macros. And for example, H5 or get info, there are now two versions, info 1 and info 2, and this corresponds, the signature corresponds to or get info 1. It's still available, and you will be able to use in our mechanism how you use different versions of APIs at compile time. You can specify which version you use, but functions are there. Don't be scared; they will not remove. Request to community is to look at binary compatibility report and just see we might miss something, and we want to fix it before the major release. So this is available. It is in the same directory where we have this report is available from the same directory where we have our source distribution. And I believe this is one of my last slides.
So I'll talk about that. We have another webinar currently scheduled for January 17th. It's called Learn More About Kita Lab. John Reed will talk about how to get started and show you some of the resources that are tucked away in Kita Lab, which is our Jupyter Labs environment for data exploration. That's something we offer a free 30-day trial for everyone. So we'd just like to get everyone on board and see what that's like and learn a little bit more about Kita. There's a link there for you guys to register. We haven't set the date yet, but our next webinar will be how to create a vol connector. So I'll post that information shortly, hopefully, and that will be scheduled sometime in the new year.
And just to add what Lori said about first webinar, I promise we will show you how RESTful that comes with the open source and with the open source HDF server that is used in Kita Lab work together. So those two solutions are available absolutely for free and available now. So please join the webinar to learn more about both Kita Lab and about open source solutions that we provide.
And you guys can use the questions area in the control panel to give us questions, and we'll answer those. You can also, at least over the weekend, well, anytime you can ask questions, but we'll try to collect questions over the weekend and write up a more complete response to post on the forum. We'll also post the recording and everything else on the forum as well as we kind of collect and package it all up. So that should be next week sometime.
And there is one question that I will try to answer, but I probably will need help from the group. Are these references using absolute status or relative status to other HDF? I cannot see the whole one.
Or could it use both?
Oh, both. So I believe, I know that references, they have two parts now. In the past, they have only reference was created from the object header address in the file. Since now we can point to external files, reference will contain file name, which can be relative or whatever file name user provides. So it's user responsibility to keep files consistent. And when you're moving files, yes, you can destroy the reference. I don't think we provide now, at this point, mechanisms that we have for other features when you move directories and we overwriting with environment variable, right, guys? You will correct me. We do not have it yet.
Not I believe, no.
Yeah, but there is a plan, so it will be much more robust mechanism when you're moving collection of your files, not to destroy the references.
Or we could provide maybe like a consistency checkout.
Consistency checkout, yes.
Like a URL, they have that for URLs.
The next question, how do I get oneself to try it with NetCDF? You just download our source code and you should be able seamlessly to compile it and relink it with NetCDF. It should work out of box. If it doesn't, please let us know now. We, with the release, even major release, we promise not to break your old applications. Any other questions?
And again, we will package up everything and have that posted hopefully early next week. But meanwhile, if you have a question but haven't had time to get it into us, please send it to Elena, post it on the forum, or send it to help@hdfgroup.org.
Thank you for listening.